Okay, question 11. Two pictures are mathematically similar in shape. So mathematically similar. That is the key word here. We've got a rectangular picture, it's 100 wide, another one that's 60. The cost of each picture is proportional to its area. The large picture costs £13.75. Find the cost of the small picture. This is quite, I quite like some of the similar shape questions. I've said it before, I like the angle questions as well. So they've dressed this up as pictures in pounds, but really what they're saying is, calculate the area of the smaller picture, okay? Because they say that the cost of the picture is proportional to its area, so we can effectively say the area of the big one is 1375. I'm actually just going to write that properly over here. So the area here is effectively 1375, and we need to work out the area of the small one. So the minute you see similar shapes, you should be thinking, well, what do I need? I need a scale factor. Let me just move this up a tiny bit. Okay, I need a scale factor. So a linear scale factor is where you should always start, your linear scale factor. Okay, and that is going to be equal to your new over your old. Now this is going to be our new, and this is our old, because we're trying to find something in this picture, so that makes it the new one. Now your scale factor has to be two corresponding lengths. Okay, so I know 160. Okay, but say they give me just imagine, right, they gave me 40. Okay, I would not use 140 because they're not corresponding lengths. Okay, this is the width of the picture, this is the width, therefore I'm going to use these two. If I knew the height and the height, I would use that, but you couldn't use, say, the width and the height together, okay, because they're not corresponding lengths. Okay, so I know 60, don't know why I've decided to use that colour pen. 60 divided by 100, new over old, is our scale factor. So we just cancel out, that's 6/10. I'm just going to leave it as 6/10. Okay, I'll divide it by 2, 3/5. Okay, so yeah, divide top and bottom by 2, 3/5. So that's our scale factor. Now, the area scale factor is equal to the linear scale factor squared. The volume scale factor is equal to the linear scale factor cubed. And obviously that can go around the other way as well. Okay, so therefore, I'll write that one here. In fact, no, I won't, I'll just write it below. So if we went the other way around, that's the same as saying the square root of the area scale factor is the linear scale factor, and the cube root of the volume scale factor is the linear scale factor. The mistake people make is when they're going from linear scale factor to area scale factor to volume scale factor. Because you're doing, linear scale factor squared, linear scale factor cubed, they kind of square root the volume scale factor to get back to the area scale factor. Okay, but really you've always got to go back to your linear scale factor. So if you know the volume scale factor, you couldn't just square root it to get area. That's not what you'd have to cube root it to get your linear scale factor, and then square it to get your area scale factor. I'll say that again, so I might have said it wrong. If you know the volume scale factor, you would cube root it to get back to your linear scale factor, and then square it to get to your area scale factor. If you knew the area scale factor, you would square root it to get back to linear scale factor, and then you would cube it to get up to your volume. Okay, again, you wouldn't take your area scale factor and just square it again. Okay, so sometimes if you're working in reverse, I'd say that's harder. Okay, but if you remember these equations, really just remembering that, because this is just the inverse of it, you won't go wrong. Okay, but that's thinking about the different ways of going. Okay, but that's the harder versions, I think, is when they give you, a volume scale factor and ask you to work out a new area and things. Okay, but all you need to do is say, well, I know volume scale factor is equal to the linear scale factor cubed, so therefore the linear scale factor is the cube root of the volume scale factor. And then once you know the linear scale factor, say, well, the linear scale factor squared is the area scale factor. Things like that, okay? But this is quite straightforward, okay? We just know the standard linear scale factor is 3/5. So therefore our area scale factor is going to be 3/5 squared. Now this is non-calculator, that would be the same as 3/5 times 3/5. So that'd be 9 over 25. I can't simplify that any further. Okay, but that's just if you were doing it in that paper. So to work out the new area, So just say new area, or new price, sorry, is going to be equal to 9 over 25, i.e. the area scale factor, times the original price of 13.75. Okay, so let's just do that on our calculators. Okay, so that's going to give us 4.95, and don't forget your units. So in this question, I've just done this just to remind us, if we were doing it non-calculator, how you could potentially write that. If that was on a calculator, that would probably come out as nicer numbers, all right? But just to remind, you could have obviously just kept it as 60 over 100 squared, right? That's totally fine. But I just thought I would make the point of showing you how to do that differently. Right, marks for that one. You get a mark for your linear scale factor. You get a second mark really just for the equation, not to square it, multiply it, and then for doing the final answer. But they're still pretty good for 3 marks. And again, if you see mathematically similar, just work out some factors, work out a linear scale factor, work out a volume scale factor, area scale factor. Just do these things, okay? Because all these marks add up, okay? And if you're not sure, just substitute in some other numbers and just see where you get, okay? Because again, if you did this with the wrong numbers, you might still get another mark for just doing that calculation correctly, okay? So just really try when you do these. Don't just, I can't do that. Okay, you probably do one thing. You want to start it off. All right, you can definitely work out a factor, a scale factor. Okay, so yeah, have a bash. Change the subject. This looks probably like the meanest change the subject one I've seen actually. So yeah, in terms of trickiness, I'd say this has got to be up there. Zoom in just a little bit. So changing the subject's interesting. It's not tricky. Just it isn't actually hard. I think practicing obviously helps, but it does seem to catch people out. Okay, and this one looks about as hard as they are. Okay, so I'd first of all rewrite that as 4kt minus p, and I'm just going to put that in a bracket and do square root. Okay, so that's how I'd write it. Now, what I like to do as well is think, well, how can if I put in some numbers here, that'll let me check it on the way out if it's going to be okay. So let me think of some numbers. Okay, so picking numbers can be tricky, right? But I know I've got a big root sign in here, so I want to have a square number in here, so this comes out as a nice normal number. So let's say I want this to be like root 16, okay, or like root 25 or something. Let's say I made k2 and I made t3. So 4 times 2 times 3, that's 8, 60, that's 24. Okay, so if I made p minus 1, that would come out as 25 and L would be 5. Okay, so there's a bit of a knack to doing that, to thinking about that. Okay, that in itself can be quite tricky. Okay, but if you're able to, sorry, the handwriting here is once again letting me down. Sorry. If you're able to kind of think like that, if you're able to try different numbers, okay, that will be helpful at the end to check we've done it right. Okay, so 4 times 2 is 8, times by 3, 8, 16, 24. Take away minus 1 gives us 25. Root of 25 is 5. So I always just start off with numbers like 2 and 3 and then see where I end up. But I was always thinking I want to get a square number in here so I could square root it nicely. Obviously, if you get a calculator, actually, to be fair. So again, in this paper, you could just put 2, 3, and 4 and see what you get with your calculator. That's fine. But nice round numbers. Just work a bit easier. So when you're rearranging, you want to start as far away from the number that you're rearranging as possible. Okay, so we're doing k. Okay, so right away I'd be thinking 4 and t will be the last things to go. Okay, and then p would be before that, and my square root sign would be the first thing I'd want to go because the square root sign affects everything. Okay, now again, sometimes it can be hard to think, well, what order am I going to do it in? Just think of doing the opposite of how you'd work that out. Okay, so how would I work out L? Well, I'd do 4 times k times t. Yeah, then I'd take away p, and then I'd square it. Okay, and we're just going to do it in the opposite direction to that. Okay, so just think about how you do the calculation normally, and we're kind of going in the opposite direction. Okay, so I would do this bit, then I would take away p, and then I'd root it. So we'd do the exact opposite of that. We're going to get rid of the root, get rid of p, and then get rid of these. Okay. So what is the opposite of? I'm going to do my working line for this as well. So you know what? I'm going to just put it, just to make it really obvious. I'm going to put my L on this side. All right. So the working line is quite cool. It's you just write down what you're going to do, and basically it appears on that side. So if I want to get rid of a square root, I need to square. Okay, so I'm going to do squared. So it will disappear from this side. In fact, sorry, you know what? I hate that I keep changing the pen. I'm really sorry. So I'm going to do a squared. I'll keep them on this side. I'll do like a squared. So on this side, that gets rid of the square root. Yep, so now we've just got our section, yep. And that's going to give me a wee L squared. Okay. Now, I want to get rid of the P. So out of take away P, I'll do the opposite, add P. Okay. So on this side, that's now disappeared. And over here, I've got add P. Okay. Now I want to get rid of the times 4 and the times T. So if I'm timesing on the left, I'm going to be dividing on the right. So I'm going to divide by 4t. Okay. So that's going to give me k. I'm just going to have to move over a tiny bit. L squared plus p divided by 4 divided by t. Okay, and it is as simple as that. So if I wanted to check I've done it right, I can go and substitute the numbers back in. So L squared was 5, so that's going to give me 5 squared is 25, plus p, which is minus 1, divided by 4t, which is 12. Okay, so 25 minus 1 is 24. 24 divided by 12 gives me 2, and I said that k was 2. Okay, so I know that I've done it right. So again, if you're not great at rearranging formulas, you at least know you'll have done it right or wrong, because you can pick some numbers to try. Okay. When you're changing size, you're just doing the opposite function. So we should really know by now the opposite of add is take away, the opposite of times is divide, square root is square. So then maybe we're thinking, it's the order that I'm not very good at. Well, you want to go as far away from where you're going to end up as possible. So we know 4 and t are going to be last anyway. Okay. And then you say, well, how do I know I'm doing the root and not the p? Well, you want to go in the opposite direction to how you'd work it out. So I was working out L, I would do this, take away p, then square root. Okay, so I want to do the opposite. So you're basically doing kind of the opposite of BIDMAS. You're doing like BIDMAS in reverse. A little bit. Not totally, but but a little bit. So yeah, just think about how you would do it, and then do the opposite. Okay, that's how you work out an equation if you were given it. And so we worked out what was inside the bracket, and then we did the index, which was this bit here. Okay, and inside the bracket we did the multiplication before we did the subtraction. Okay, because multiplication's up here, subtraction's down there. So it's hard. There's not I can't think of an instant formula. Hopefully as I work through more of these, I'll think of some more tricks to do it. I'm sure someone can explain it better than me. But yeah, that's the way I think on it, is how would I do this? I'm going to do it in reverse. And obviously to move something over, you do the opposite function. Okay, but yeah, like anything, practice, practice, practice. There's 3 marks in this question. Does not take a genius to work out. You're getting a mark for each point. Okay, so the square, the add, the divide. Okay, that's where you're getting your three points from. Okay, actually, be like the L squared, that, and that. Okay, so yeah, hope that was helpful. Think about how you would do it. In fact, I'd say the best bit of advice I've got is probably that little check where you put numbers in to give you what L is, and then you can double check that you've done it right. That's probably the best bit of advice I've got for these questions. Okay, so hope that was useful.